Assalamualaikum and hi guys. For the previous lesson, you have learned on how to find the Laplace transform by using table of the Laplace transform and by using the properties of the Laplace transform. And then you also have learned how to find the inverse Laplace transform by using table and also by using the properties of inverse Laplace transform. So today, for the last subtopic, you will learn on how to solve initial value problem by using Laplace transform. So today we will continue for the last subtopic, which is how to solve initial value problem. Consider for the first order differential equation and second order differential equation by using Laplace transform. So the differential equation that we want to solve is divided into first order differential equation and second order differential equation. So first order means that the highest derivative is y prime. The second order differential equation means that the highest derivative is y double prime. So for the first order differential equation, you have learned before this, we can solve by using separable, homogeneous, linear and exact. For the second order differential equation, you have learned before this, we can solve by using MUC, method of undetermined coefficient, whereby you have to determine whether that question is from case 1, case 2 or case 3. And the second method is by using variation of parameter. But if the question mentioned by using method of Laplace transform, so you have to solve the following question by using Laplace transform. So in order to solve the initial value problem by using Laplace transform, you have to transform the derivative, which is Laplace yt will become ys, Laplace y prime t will become sys minus y0, Laplace y double prime t will become s square ys minus sy0 minus y prime 0. y0, y0 and also y prime 0 is the initial condition that given in the question. For example, this is the initial condition y0 equal to 2. So this is also the initial condition for this question. We have y0 equal to 0 and y prime 0 equal to 1. So in order to transform the derivative, you only have to remember that Laplace yt equal to the ys, Laplace y prime t and Laplace y double prime t. This one you can refer to the table of the Laplace transform. This is the summary of the step on how to solve the differential equation by using Laplace transform. So you will be given the problem in terms of first order or second order differential equation with the initial condition. Okay, by using the Laplace transform, you will convert the differential equation into ys equal to something. So something on the right hand side here is depend on your question. And then from the ys equal to something, we will proceed for the next step, whereby we will take the inverse Laplace transform for the ys, which means we will solve for the inverse Laplace transform. For the last step, the solution of the yt is found. Okay, now let us try to solve this example. This one I take from exercise 4.9, question A, page 150. By using method of Laplace transform, solve the given differential equation. So you are given y prime minus 5y is equal to 15t and the initial condition is y0 equal to 2. For the first step, apply Laplace transform for each of the term and then simplify. So means that we have to write Laplace transform for the left hand side and Laplace transform for the right hand side, and then we need to simplify. Laplace y prime minus Laplace 5y is equal to Laplace 15t. So if we have any constant inside the curly bracket, then we have to bring the constant to the front. So Laplace y prime, there is no constant. So Laplace 5y, the constant is 5. So bring 5 to the front. So Laplace 15t. So bring the constant 15 to the front. Laplace y prime minus 5 Laplace y is equal to 15 Laplace t. So now by refer to the table of the Laplace transform, simplify the Laplace y prime. So y prime t is equal to sys minus y0. So you have to substitute sys minus y0 to the position of the Laplace y prime. So therefore, sys minus y0 minus 5 Laplace of y. This one is not given in the table of the Laplace transform, whereby you need to remember that Laplace of y is equal to ys. So therefore, Laplace of y here will become ys equal to 15 Laplace of t. By refer to the table of the Laplace transform, t the power of n will become n factorial over Sn plus 1. So for this one, our n is equal to 1. N is equal to 1. So therefore, 15 will be multiplied 1 factorial over Sn plus 1 will become 2. So now you have to apply the initial condition. Sys minus y0, substitute y0 equal to 2, minus 2 minus 5ys is equal to 15 multiply 1 factorial over s square will become 15 over s the power of 2. Okay, now proceed for the second step. Simplify into ys equal to the something. So in order to simplify ys equal to the something, we need to factorize the ys. So from here, in order to simplify ys equal to the something, we need to factorize the ys. So ys at the front. So ys multiply with what? So that it will become sys. So it will be multiplied with s. Ys multiply with what? So that it will become negative 5ys. So minus 5. So for the negative 2 here, we just write at the behind here negative 2. Is equal to 15 over s the power of 2. So we want to make sure that only ys on the left hand side. The rest you have to bring to the right hand side. So on the left hand side now, we have ys multiply s minus 5 minus with 2. So we want to make sure that only ys on the left hand side. So the rest here, we need to move to the right hand side. So we have to move one by one. Move negative 2 first to the right hand side. Ys s minus 5 is equal to 15 over s the power of 2. Bring negative 2 to the right hand side will become positive 2. So now on the right hand side here, if you can see that the denominator is not the same thing. This one is 15 over s square. This one is 2 over 1. So we want to make it become same denominator. So how to make it become same denominator? We have to cross multiply. So simplify the right hand side. On the left hand side, we just copy down. 15 multiply with 1 will become 15. 2 multiply with the s square will become plus 2s square. Divide with s square multiply with 1 will become s square. Okay, now move s minus 5 to the right hand side. So ys is multiplied with the s minus 5. When we move s minus 5 to the right hand side, this one will become the term at the denominator. So therefore, ys is equal to 15 plus 2s square divide with s square multiply with s minus 5. So now we already obtained that ys is equal to something. So this is what I mean by the something on the right hand side. Now proceed for the next step. Solve inverse Laplace transform, which means that you have to write Laplace inverse curly bracket for each of the term, and then we need to solve accordingly. Laplace inverse ys is equal to Laplace inverse 15 plus 2s square divide with s square multiply s minus 5. Laplace inverse ys will become yt. Laplace inverse 15 plus 2s square divide with s square multiply s minus 5. So on the right hand side here, we need to solve inverse Laplace transform, which means that you have to apply back everything that you have learned for the properties of the inverse Laplace transform. If we have something multiply something at the denominator, means that we have to solve inverse Laplace transform by using rational function. So on the right hand side, we need to solve by using rational function. So recall back what is the step in order to solve inverse Laplace transform of the rational function. So first you have to write in terms of the partial fraction. So s square here, this one is a repeated linear term. S minus 5 is a linear term. So therefore, for the s square here, the partial fraction will become a over s plus b over s the power of 2. For the s minus 5, this one will become c over s minus 5. Okay, now find the value of the constant a, b and c by eliminate all the denominator at the bottom side. Okay, on the left hand side, so we always copy down whatever we have at the upper side. 15 plus 2s square is equal to a is divided with the s with the power of 1. So on the left hand side, we will close s with the power of 1. So the things that still open, which is s and s minus 5, will be multiplied with a. So a multiply with s, multiply s minus 5, plus b. b is divided with the s the power of 2. So on the left hand side, we will close s the power of 2. So s minus 5 will be multiplied with b. Plus c is divided with s minus 5. So on the left hand side, we will close s minus 5. So s the power of 2 will be multiplied with c. c multiply s the power of 2. So now in order to find the value for a, b and c, I will use the method of expand and compare the coefficient. So on the left hand side, there is nothing that you have to expand. So we just copy down. 15 plus 2s square is equal to a multiply with s, multiply with the s will become as square. A multiply with s, multiply with the negative 5 will become negative 5as. B multiply with s will become bs. B multiply negative 5 will become negative 5b. C multiply s square will become cs square. So now compare the coefficient. The highest power of s is s power 2, s power 1, s power 0. On the left hand side, s with the power of 2, we have positive 2. 2 is equal to, on the right hand side, s with the power of 2, we have a plus c. A plus c. So this is our first equation. For the s with the power of 1, on the left hand side, there is nothing s with the power of 1. So therefore, left hand side will become 0. On the right hand side, s the power of 1 is negative 5a plus b. So this is our second equation. For the s with the power of 0, on the left hand side, there is nothing multiplied with s is 15. 15 is equal to s with the power of 0 on the right hand side is negative 5b. So this is our third equation. So find the value of the constant a, b and c by using calculator. So therefore, by using calculator, the value for the constant a is negative 3 over 5. Constant b is equal to negative 3. And constant c is equal to 13 over 5. So now you have to substitute all the constant here into the position of the partial fraction that you have right before this. Okay, so this is the partial fraction that we have right before this. So for the left hand side, we just copy down back. And then for the right hand side, we need to substitute all the value for the constant a, b and c. So a over s will become negative 3 over 5 over s. Negative 3 over 5 over s plus b over s square. B will become negative 3. Negative 3 over s square plus c over s minus 5. So c will become 13 over 5. So now this one we need to solve inverse Laplace transform. So write Laplace inverse for every single term that we have. Laplace inverse 15 plus 2s square. This one is equal to yt. So on the left hand side, we will write Laplace inverse 15 plus 2s square over s square multiply s minus 5 will become yt. Yt is equal to Laplace inverse negative 3 over 5 over s. Negative 3 over 5 is a constant, so bring the constant to the front. The same thing for the negative 3 and 13 over 5. 1 over s minus 3 Laplace inverse 1 over s square minus plus 13 over 5 Laplace inverse 1 over s minus 5. So now refer to the table of the Laplace transform in order to solve Laplace inverse 1 over s. By referring to the table, a is equal to a over s. So therefore, Laplace inverse 1 over s will become a. So from here, our a is equal to 1. For the second Laplace inverse 1 over s the power of 2, this one will become t the power of n. So for our question here, our n is equal to 1. For the third Laplace inverse 1 over s minus 5, the suitable one is 1 over s minus a. So therefore, our answer will become exponent at. So our a is equal to 5. So now write the answer based on the value that you have declared. Negative 3 over 5 multiply with 1 minus 3 t the power of 1 plus 13 over 5 exponent 5 t. So write back negative 3 over 5 minus 3t plus 13 over 5 exponent 5 t. So this is the final answer for the first example.